Hello guys, so in this video we'll be talking about composite functions. So just a little recap to refresh what we learned last time was we learned about single functions where they connect two different sets. So as you can see, the lines connecting in between them are our functions. This could be a one-to-one function or a many-to-one function. So these are the kinds of simple functions that we've learned previously. But in this video, we'll be talking about composite functions. And to just visualize what composite functions are, here's like a little rough drawing that I've made to represent composite functions. So if we're all familiar, we're most familiar with the functions where they connect just two different sets. But in this drawing over here, we are given not two, but 1, 2, and 3 sets. And between each of these sets are connected by a function. Two different functions, in fact. And if you can see between set number 1 and set number 2, there is a function, which is fx. And there's another function which connects set 2 and set 3, which is called gx. Okay, so let's try to think. What is a composite function? Well, a composite function is basically a combination of two functions. So what this helps us is, this helps us to find the image of an object from set 1. And what I mean is, we do not have to go one by one to find the corresponding image in set 3. This composite function immediately helps us to find what is the corresponding image for the object in set 1. So let's try to have a look at this visualization here. So over here, we are given fx and gx. So how do we form a composite function? Form composite function. Well, the simple way is, let's think of a bridge. So the bridge is, first you have to go through bridge fx, and then the next bridge you have to take is gx. So why don't we write down the first bridge we take, because that's our first step, which is f of x. And the next bridge we take is g of x, which is the second one, and we just have to write it in front of the f. Now you might be confused, wait, what did I just do? Well, a way to make this more easier is, this f of x over here has simply become the object for the function g of x. And what I mean is, it has become like this. So basically, the f of x in here is technically the x value of gx, of the function g. So whatever that is thrown into the function f gives us a value in set 2. And that value in set 2 becomes the object for the image in set 3. I hope you guys understand the visualization and the clarification I gave. So just to summarize once again, the f of x inside, why the first function is always inside is because the function inside acts as an object for the next function. So whatever is produced from the function f of x is thrown into the function g of x to give us our final image, which is in set 3. A little tip is the beginning function is always the one inside. And what I mean inside is over here. As you can see over here, we have g of fx. And the one inside of this whole expression here is always the first function. Like over here, this is, sorry, I made a mistake here. So as you can see, the f of x here, this is the first function. So this will be our beginning function, the function which starts the entire reaction, the entire flow. Okay? Alright, so let's just jump into some simple questions to maybe help us understand even better. So two functions are defined by f of x, which is equal to 2x, and g of x, which is equal to x squared minus 5. Determine the following composite functions. So we are given to find the function of fg, gf, f squared, and g squared. Now maybe you could try to solve this by yourself, and you could like pause the video and try it yourself, or you could just watch how I do it. Okay, so let's try to solve the first one, which is fg. So let's try to apply the concept that I explained earlier. As I mentioned, the one inside will be the first function, so that will be the object for our second function. So maybe you could rewrite it this way. Okay, so the g of x acts as the x value in f of x, this one. So technically we can just rewrite it as x squared minus 5. Okay, so this is our x value. And what do you do to the x value when you want to find the image of it? So technically we have to substitute this x value into the function equation. And what I mean is we have to substitute this x squared minus 5 into fx. So fx is 2x. So technically it's 2x squared minus 5, which gives us 2x squared minus 10. And this, my friends, is the function fg of x. This is the composite function. Okay, so why don't we jump into the second example, which is g of f. And this is simply the same concept. You just rewrite it, and the f of x will play as the x value for g of x. Okay, so technically we just have to rewrite the f of x in here, which is 2x, and the next step is to sub in that x value into g of x to get our image. And our g of x is technically x squared minus 5, which is 2x squared minus 5, which gives us 4x squared minus 5. So this is the answers for the first two questions. Now let's jump into the third question, C, f squared x. Now when you look at this, it may be a bit confusing. Some of you might think, am I supposed to square the entire function like this? Well, to simply make this more easier, if you could remember, if x is multiplied by x, let's say y is multiplied by y, using the law of indices, we get y squared, don't we? Or normally we could write them like this, right? Okay, so let's apply the similar concept here but in this case it's functions. We don't have to write the multiply symbol. We could simply write f and f of x. So just assume that these two functions multiply to give you f squared. And we can rewrite this again in this form. And again, just sub in the values for f of x, which is 2x. And this one acts like the x value. And just sub it into the function again, which gives us 4x. And that's our final answer. And our last question will be g squared x. Using the same concept, we just have to sub it in. And inside the function, we have to add our g of x, which is x squared minus 5. And we have to sub it back in again. Okay, and I think we have to expand this, where if I were to expand this, we would get yes, this would be our final answer. Okay, so the reason why I did these simple questions was to show how I solved it. And number 2 is the concept of solving. So you get a rough understanding of how I overcome and go through these questions. Okay, so there are instances where we are given a function, a composite function, but we are to find the image of the function. Like what I said earlier, we are given a function, a composite function, but we have to find the outcome of the input. So I just given here 2 simple questions to solve this, where in A, we have to find fg2 and we have to find gf1. Let's try to solve the first one. So we're given fg2, and now you might be confused. Wait, we have an input. How am I supposed to overcome this? How am I supposed to solve this? Well, let's take a moment to neglect that 2 first. Why don't we try to find what is fg of x first? And with that, we can, once we find our composite function, we can sub in the 2 and we'll get the wanted image. So with that, let's try to do it. fg of x and g of x would be x squared minus 3x plus 4. And we just have to sub this equation into f of x, which is x squared minus 3x plus 4 minus 1. And we'll finally get x squared minus 3x plus 3. This is our composite function. And now we have to find what is the output for the x value of 2. So simply just sub in the value of 2. And we should get 1. Okay, so that's a very straightforward way of answering this. And after this, I'll show you another simple way of actually solving this. But let's just go through the generic concept of solving. And in the second one, we have gf of 1. Applying the similar concept. Okay, so just sub the function inside f of x and take this x minus 1 as the x value of g and sub it inside the function. 1 squared minus 3x minus 1 plus 4. And we can expand this and rewrite it one more time. 5x 178. This is our final composite function, and all we have to do is sub the 1 back inside, which is 1 squared minus 5(1) plus 8. And with that, we should be getting our answer 4. Okay, that's pretty straightforward, isn't it? And over here, wait, let me just minimize this a bit. It might be a bit messy, so forgive me for that. Let me just make space for question B. In question B, we are given the composite function fg of x is equal to 7, and they want us to find the x values which give the value of 7. So this is a little tricky at first. But if you can see earlier, we kind of found our value for the function fg of x. And it's this equation over here. So what they're saying is this equation is equal to 7. And we want to find the x values that give us 7. So simply, we can just rewrite this and just put in the equation equal to 7 and solve this as a quadratic equation. So just take 3 minus 7, which gives us negative 4 is equal to 0. And next, we can just factorize this to give us x minus 4, x plus 1 equal to 0. And that leaves us with x equal to 4 and x is equal to negative 1. So this 2 gives us our image 7. Pretty straightforward, right? Now, a little fun way of solving the composite questions are, so let's say we have this question again, fg2 and gf1. Another way of solving it, if you truly understand the concept, was remember that g2 is the first function. So this value is the one connecting between the first set and second set. And the x value inside this bracket comes from the first set. And the second function here basically takes the value from the second set to the third set, where our third set is the image. And the second set is basically the product, the value of g2. So what if I just found what is g2 first? And we're given the function g is x squared minus 3x plus 4. So I could simply just sub it in the equation. To give me 2. So this will be the value in the second set. And all I need is to sub this in the next function, which is f of x. And I can just sub it again as x minus 1. So it becomes 2 minus 1, which gives us 1. Don't you realize that we get the same answer? So that's pretty interesting, right? And in the second example, we are given gf of 1. So f of x over here is the one connecting the first set and second set. And this 1 over here is from the first set. So all we have to do is find the value in second set and sub into g of x. So what we can do is we can find what's f of 1. And if you can remember, f of 1 is technically x minus 1. And we take 1 minus 1, it gives us 0. So all we have to do is sub 0 into the function g of x. And that gives us 0 squared minus 30 plus 4. And our final answer is 4. See? It's the same. So this is a very maybe more faster way to solve this. But the reason why sometimes we have to find the equation is because in exams, there could be a possibility where question B is demanding the function, and you would have to construct that function again and again. You have to construct the function and solve it all over again. So to make it easier, you could just find it in the first question and just apply the same function into the second question. Alright, and for the final part of our video, so this part is rather interesting. So we are trying to determine a function when a composite function and one of the functions are given. So over here, we are given one of a function, the composite function, which is fg of x, which is equal to 8x minus 7. And a function given to us is f of x, which is x minus 2. So if you could actually realize that this over here is the second function that links the second and third set. So how are we supposed to find g of x? What we want to find here is g of x. Okay, let me rewrite this in equation form. 8x minus 7. And we have the function f of x equal to x minus 2. So we can just use the similar concept earlier, where the g of x is technically the object for the second function f of x. So understanding that, we can assume that this g of x over here is the x value for f of x. So we can rewrite this like this. So we have our function fg of x, and we can assume this part as an x. So what we can do, as this is the x value, this is the x value of our function, we can just write it like this. Minus 2 is equal to 8x minus 7. See, what I did over here is basically this is the x value. It's in here. So all I did was just sub it in here and made it equal to this entire equation again. So we can solve for g of x, or you could say solving for the x. Okay, so just move the 2 here and we should get 8x minus 5, because negative 7 plus 2 is negative 5. So that's our answer. We found gx is equal to 8x minus 5. You can try it out by subbing in. You can try it out by using f of x and g of x to get back the initial function to see if you got the right answer. And the final and second example I've given here is g of x fx is equal to x squared plus 3x minus 5. And our given function is the same function as earlier. F of x is equal to x minus 2. So again, let's just rewrite the equation. Squared plus 3x minus 5. And we're given the function of f of x is equal to x minus 2. So using the same concept, so our f of x here is technically the x value of g of x. And over here, this is like our x value. So what we can do is we can sub this into the x value. And what I mean is, here, let me show you. So, wait. Yeah. So what we can do is, I think I made a mistake here. Sorry. We're actually given, g of x. I'm supposed to write g. So this is the new equation. Sorry for the mistake earlier. and this is the function g of x equal to x minus 2. So again, our gx acts as the x value. Sorry, what am I doing here? Wait, f should be the outside. Okay, yeah. Alright. So this function, all we have to do is the f of x acts as the x value for g of x. So all we have to do is the same concept, just take this as the x value, alright, and all we have to do is just sub it back into the equation. So what we have to do is f of x minus 2 is equal to x squared plus 3x minus 5. And to solve it, we get back x squared plus 3x minus 3. So that's our final answer. I think I made it a little confusing earlier because I mistaken the notation. Okay, so I'm really sorry for that. So our function given is g of x is equal to this, and our given function is g of x equal to x minus 2. So we have to find what is f of x. So you can see f of x is the first function, and we are given the second function. So we know that this f of x acts like the x for g of x. So all we have to do is sub the f of x like the x in g of x and solve it and find for f of x. Okay guys, so that's the end for this video. I hope you understood about composite function and most importantly the concept behind it. So that's all for the video. Thank you guys for watching.